In this example and also exercise A, you're going to use these standard integrals in order to find more complicated integrals. So in example A, we've got the integral of these three terms added together. So a fact that you need to know is if you've got the integral of lots of terms added together, you can integrate each term separately. So you wouldn't be expected to write this out. So just to make it clear in this example, I'm going to split this up into three separate integrals. So I could split this up into the integral of 2 cos x plus the integral of 3 over x plus the integral of minus root x dx. I kind of got a plus there before the minus. And actually, another useful fact is that you can take a constant outside of the integral. So you can factor out a constant, kind of treating the integral symbol like a bracket. So I could write that as 2 integral of cos x. And I can factor out a 3 outside of this integral. And I have 1 over x inside the integral. And I can factor out a minus 1. And I could write that as minus root x dx. So each of these integrals are standard integrals that we can either remember or get from the formula book. So to integrate cos x, we're thinking about this diagram. If you integrate cos x, you get sine x. So we can write this as 2 sine x plus 3. And then if you integrate 1 over x, we've learnt that that's natural log of the modulus of x. And to integrate root x, we're going to write that as the integral of x to the power of a half, because this is just a x to the power of something term. So we've got 2 sine x plus 3 natural log of the modulus of x minus, and then to integrate this, we're going to increase the power of x by 1, so that's 3 over 2, and then divide by 3 over 2, divide by the new power. So we can neaten that up a little bit, because if you divide by 3 over 2, that's the same as timesing by 2 over 3. So we can write that as 2/3 times by 3 over 2, x to the power of 3 over 2. The integral in B is less obvious, so let's start off by splitting it up into two separate integrals. So we could write that as the integral of cos x over sine squared x dx plus the integral of minus 2 e to the x dx. And you wouldn't necessarily need to write this step, and you could just jump straight to this is the integral of cos x over sine squared x, and we can take out the minus 2 as a factor outside the integral, so we could write that as minus 2 integral of e to the x dx. And you could just jump straight to that step from the question and miss out this step here. So we need to try and relate this to our standard integrals. So if you have the list of standard integrals in front of you, it would be useful. Well, the standard integrals are generally phrased in terms of cot, cosec, tan, and sec. So you can actually get cot and cosec out of this fraction. If we write it as cos squared x over sine x multiplied by 1 over sine x, then these two fractions multiplied together is equivalent to cos x over sine squared x. And the reason why we've done that is because cos x over sine x is cot x, and 1 over sine x is cosec x. So now we've got two integrals which you should recognise how to integrate. The integral of cot x cosec x is minus cosec x, and the integral of e to the x is just e to the x. So we're going to have minus 2 e to the x plus c. If you forgot what the integral of cot x cosec x is in the exam, you've actually got that in your formula book. It's not in the integration section, because cot x cosec x doesn't appear in the integration section, but it does appear in the differentiation section. You can see that if you're integrating minus cosec x cot x then you get cosec x. So we're integrating positive cosec x cot x, so we're going to get minus cosec x. Another way of thinking about it is we're thinking about what function differentiates to cot x cosec x. Well, we need a minus cosec x to ensure that when we differentiate this, we get positive cot x cosec x.